In this video, we are going to discuss about Millman's theorem. It is also called as parallel generator theorem. Here, the given circuit should be read-on as a parallel network of branches, and each branch should consist of a resistor which in series with a battery. Okay, so the Millman theorem is applicable only to the circuits which can be read on accordingly. So if we see for this branch you have a battery and resistor. In this branch you don't have any battery. That is, the voltage is 0, and here you have a resistor 8 ohm, and here you have a 7 volt battery and 1 ohm resistor. Okay, so suppose if I want to find the current I through this resistor, we need to find the overall voltage. So the overall voltage is nothing but so here I can take this one as a VA. Okay, from here to here, so I can write VA is equal to, okay, for this one it is 28, right? Here it is 28, divide by the resistor. Okay, the resistor value is 20. Okay, plus here the voltage is 0. Okay, 0 divided by this resistor. Okay, the resistor value is 8. Again here the voltage is 7 divided by 1, divide by 1 divided by 20. 1 divided by 20 is 1 divided by this resistance plus 1 divided by this resistance plus 1 divided by 1. Okay, so if I solve, I will get 28 divided by 20 plus 7. Okay, divide by 28 divide by 8 into 12. Okay, plus 1. So what is the answer? 28 divided by 20. So what is 28 divided by 20? 28 divided by 20 plus 7. It is 8.4. Okay, 8.4 divided by 28 divided by 20 divided by 8 plus 7. It is 1.175. Okay, so 8.4 divided by 1.175. It is 7.148. Okay, so we have found out the value of VA. So if I want to find the value of I is equal to VA divided by 8, right? So VA is 7.148 divided by 8. So what is 7.14 divided by 8? It is 0.8935 amps. Okay. So before this one, why we should find how come this formula came? That is VA is equal to this one. Okay, for that so we know this is a circuit. Okay, here you have 0 volt, right? Let me take this one as R1. R2 and R3. Okay, and this one has E1, E2, and so for this one the equivalent circuit for this one is I can draw like this also, right? So this is called as source transformation, right? So this R1 instead of voltage in series with resistance, I can draw it as current source in parallel with this resistance. So the current value is E1 divided by R1, right? So this I can replace it as R2. This is R2 in parallel with E2 divided by R2. Okay, so this will goes on. This is Rn in parallel with So if I want to find the R equivalent value, what I should do, I need to open circuit this current source. If I open circuit the current source, the R equivalent value, okay, R equivalent value becomes so if I open circuit this current source, I will have only this resistor, right? That is, this is R1, and here you have R2, and here you have Rn. So you can see R1, R2 and Rn are in parallel. Therefore I can write 1 divided by R equivalent is equal to 1 divided by R1 plus 1 divided by R2 till 1 divided by Rn. So this is your R equivalent value. And if I want to find the value of I equivalent, okay, the I equivalent value, so here you can see this current this current will flow through the minimum resistance. So here the entire current from E1 by R1, this current will flow only through this direction. So here it will not, the entire current will flow only through this path, right? So again the current flowing through this one is 0, and here it is E2 by R2, and here also it is En by R1, here it is 0. So I can write I equivalent is equal to, okay, this current is E1 by R1 plus E2 by R2, and it goes up to En by Rn. Okay, so if I want to find the voltage, okay, that is V equivalent, that is nothing but I equivalent into R equivalent. So I can write this one as I equivalent divided by 1 divided by R equivalent. What is I equivalent? I equivalent is I1 by R1 plus E2 by R2, and it will goes up to En by Rn. Okay, so what is 1 divided by R equivalent? 1 divided by R equivalent is 1 by R1 plus 1 by R2, and it will goes up to 1 divided by Rn. So this I can write it as summation of Ei by Ri, where I is equal to 1 to n. Okay, and this is nothing but 1 divided by Ri. So this is how we have find out the theorem for this. This is a formula for the Millman's theorem, and this theorem is not applicable for unbalanced bridge circuit, and we can solve the problem using the help of nodal and mesh analysis itself. So why we are going for Millman's theorem is it is like an extra tool, okay, which will helpful to find the value of voltage and current across the each branch. Okay.